This video concerns understanding EI fragmentation with MS Interpreter, and it is part of my free NIST GCMS software lab for universities. It includes both a video and a handout, and you really should look at both of them to totally understand the topic. There's a lot of information, and this one in particular is something I created with ChatGPT that kind of gives an overview of it. So take a look of that. Take a look at that later. But the key take-home messages from this approach is Mass Spec Interpreter explains why peaks occurs. It links chemical structure with fragmentation. It transforms mass spectra into understandable chemistry. It complements library searching. It does not replace it, though, and is one of the best educational tools available for learning EI mass spectrometry. So let's go to the software to demonstrate it. So let's open the software. MS Search version 4. Instead of processing the file again, it always has the files stored, so I can go and reopen EI results. And I'll pick the Grove mix that I've done in the past as a good example. I'll open it. That way you don't have to process it and take all the time wasted doing that again. So I pretty much got it set up. I want to show you how MS Interpreter works with the compound. Here's a methyl ester, unknown on the top. This is probably a really good match for that. It weighs 214. So if we come down and left click on the entry, which is the peak there, and then right click and say send to MS Interpreter. So what you see here is your mass spectrum below, the EI mass spectrum, and you see the structure at the top. And then you see some information about the ion and some other things on the left about other various things that we won't really talk about here. But if it's in black, it thinks it has an explanation of how the mass spectrum correlates to the structure. So if you click on an ion like 74, I just clicked on it, you can see that it thinks it's this part of the molecule. And if you look up at the top here, 74, it shows you what the loss is. It shows you something about the relative rate, etc. So it looks like a really good possibility, and there's only one possibility. Now, if you go to the 43 ion and click on it, you'll see up here there's one of two. So it thinks it could be that part. I think it's more likely the 43 over here. So if you click on the ion a second time on the same ion, see it changes to 2 of 2, and that's probably a much more likely structure for that ion. So that's pretty much how you use it. You can expand it just like any spectrum that you want to. Double left click to make it go back. So pretty much the standard interface. It has some help built in. It doesn't say much about it in the manual, but if you go to help, index, there's some information there about it. That's very good. And on my website, I have a link in the resources that has a very intense or very full explanation of MS Interpreter if you want to take it to another level. So you can take a look at that under the resources on the course. So that's pretty much the basics. The other thing you might want to check is the options. So I'll right click here and with the options, you want to make sure it marks the isotope peaks. And I'll show you why that's important for another example, but it should be ionized, show fragments. So this is pretty much the defaults there and say, okay. So now I want to show you something that's a little bit more complex. Here's another example, and again, we'll open up one that I've already analyzed. So analyze, reopen EI results. We'll bring up this adjuvant test file. Peak I'm interested in to show you the example is this one right here. It thinks is trichlorobenzene, which you can see is a relatively very good fit. It's over 941 out of 1,000 fit, so very good. You could just send it to MS Interpreter here, but I want to show you can do it from other windows too. So we'll say library search to throw it over to the library search. And it brought it up over here. Now I can right click on that because it has a structure and say send to MS Interpreter. And so it goes from there also. You can see here it's a little bit more interesting because it also, these little yellow marks show you the theoretical isotope ratio for something that contains 3 chlorines. You can see it matches really well, so that makes you feel good about the identity, and actually the quality of the spectrum is reasonable. If you click on 149, you can see that it's loss of one chlorine. Up here is one of three, so if you click on it again, you'll just see it can lose any of the three chlorines. So it shows you all three of threes. They're all the same, really. 109, loss of two chlorines. Again, the isotope pattern matches well. The red is some type of rearrangement. It's a little bit harder to explain, so it's not straightforward. And the yellow is the same thing also. So the blacks are very certain. The whites are unknown. The yellows are a little bit less certain, and the reds probably some type of complex rearrangement. But again, a lot of very useful information you can get in MS Interpreter about understanding fragmentation. So as you learn the software, besides just pushing the buttons, start trying to use MS Interpreter to learn how things fragment so you can, in the future, identify your own unknowns. Good day.